Hello, everybody. Before I welcome our guests, I'd just like to invite those who've not already done so. Please subscribe to our YouTube channel, Magnimind Academy, where we upload recorded sessions of these talks so you can watch them later. Also, please comment any questions you have or just let us know what you think about today's talk in the comment section below. Now I'd like to welcome Andrei Lopatenko, who will be giving a workshop on multi-billion search engines, AI, and data science. At Magnimind, we really try to find speakers who can give us these workshops that have a lot of different current information and give you a new perspective on to go along with our data science education programs. These new programs kind of range from focusing on maybe one or two fundamental skills of data science all the way to helping your entire career change into the industry. And we're actually starting a new session of our Python for Machine Learning mini bootcamp, which is a free bootcamp that will help some skills in Python, and it is led by our instructor, Tyler Bedelion, over a 5-week period. Our goal at Magnimind is impacting as many careers as we can, and this is just one way that we do so. Andrei joins us as the VP of Engineering and the Head of Search and Conversational AI at Zillow. And before this, he has had a lengthy data science career with stints at Oslo, eBay, and Pine Biotech of Palo Alto. He also has degrees in theoretical physics and applied mathematics and informational technologies from Moscow Institute of Physics and Technology and a PhD in computer science from the University of Manchester. He'll be talking about new technologies that large corporations such as Apple, Google, and eBay use in their day-to-day processes, as well as how to build your own career working for these companies. And we're really excited to have him. Please now give your full attention to Andrei Lopatenko.
Can I start? Hi, my name is Andrei Lopatenko. Let me share my screen so I can start my presentation. 1 second. Okay, share. Let me go to view, like 1 second. Present. Do you see my presentation now? Let me go back, sorry, back to meeting.
Yes, it looks good.
Okay, 1 second. Let me go back to meeting. 1 second. I don't see my presentation now. Just 1 second. Zoom. Sharing is paused. 1 second. Resume share. Sorry, somehow I don't like. Okay, perhaps I have to go back here. Windows.
I can see it fine.
You see it fine? 1 second.
Sure.
Somehow I don't see my Zoom screen as my Zoom screen now. 1 second. 1 second. Okay. So do you see if I change slide? Do you see a new slide? Thomas, do you see that there is a new slide because somehow like I don't see my Zoom window?
I see it. Looks good.
Okay, yeah. So like who I am. So my name is Andrei Lopatenko. I am a VP of Engineering in Zillow Group. Before Zillow, I was co-contributor to Google Search. Basically, we started quite early. I started quite early in Google when Google just started to be the first search engine on the market. I was co-contributor to Apple App Store, iTunes. I co-designed and complemented Apple Map Search, Walmart grocery search. I advised a startup, Oslo, which was acquired by Facebook. Has been leading search teams in Zillow, Walmart, eBay, not only search but conversational AI. PhD in computer science from University of Manchester, United Kingdom. And basically my career since after my PhD was always around search, about building big machine learning based, data science based, artificial intelligence based, consumer oriented systems. So what's my goal for this talk is to demonstrate that artificial intelligence, machine learning, data science are useful tools in building search engines and building multi-billion users like systems. And they used there are several there are a lot of articles about using AI and machine learning for search. Typically, they focus now on query understanding, but actually it's a very small part of the picture. So I want to give a full picture how AI, machine learning, data science is used in search, and it significantly improves customer experience, revenue, gross merchandise value, operational cost, and helps to get more customers and serving them better. I want to show how AI is applied, data science is applied, and what's a good ways to apply to this. And also I want to share some career advice, how to build a good successful career in machine learning, in artificial intelligence, what makes good engineer or data scientist, and in long term, what are my kind of observation, what works well to build career in long term. So my message out of this talk is that successful artificial intelligence in search, successful AI in search is AI infrastructure, engineering insights, and tool set enabling to continuously introduce, measure, and improve AI features. So it's not like some one AI feature, let's introduce some state-of-the-art BERT or whatever model. Not. It's more like about building infrastructure, which allows to develop AI features, AI products, AI models in different types or in different parts of search stack, and continuously do it and improve this rather than one or several state-of-the-art models in ranking query understanding. And the same applies to every large-scale consumer or business-facing platform. Would it be recommendation engines, call center analytics, anything else? It's not one advanced AI model, it's an infrastructure. It's a set of AI models, continuous work to improve them. So for purpose of this talk, what is artificial intelligence? I will combine, there are multiple definitions. What is AI? I will talk about advanced ways how to get insights from data and move and make some action decision. It will be machine learning, data science, statistical decision theory, statistics, natural language processing. Conditionally for this talk, they will be named as AI. How to make right decisions for such tasks. What's a search engine? So a customer-facing engine which, given query, returns set of answers. Query is not necessarily as Google query. When you type something, it can be your location, it can be product ID. So search engine can be a recommendation engines. They can be local recommendations. They can be personalized recommendation. Many other types. For me, from data science AI point of view, they're really search engines. So I unify them all for the purpose of this talk. And by multi-billion search engines, multi-billion, I mean customers, dollars, customers. So I'm not talking about some small search engines which you can fastly with Solr, with very narrow purpose, search for some, for some forum which you don't really care about quality, you don't really care about user satisfaction, you don't care about computational cost. I'm talking about big search engines which have some many billions of dollars in revenue, gross merchandise value or something else, which means if you improve quality by 5-10%, you will get a big value which justify your expenses to improve the search engines. About billions of hundreds of millions of users, billions of documents, and this infrastructure, this scale justify investment in building AI infrastructure and building teams, and justify why you have to work on the search engines to improve customer satisfaction, revenue, and so on. So high level architecture of typical search engine. It may be different for different search engines, but it's more or less shared across all of them. So typically you have some frameworks how to models how to do data acquisition. They can be very different, right? It can be in case of web search engine, it's some crawling infrastructure which goes on the web and crawls website. In case of, let's say, you have e-commerce shopping, e-commerce engine, or a music engine, you consume some feeds provided to you by multiple providers which have information either about products or about music tracks, or app store about apps, or the input is through some certain a data acquisition framework. Then you have indexing, which takes all this information, process it. Actually, it's a lot of insights. Frequently, it's not just simple transformation to index. There are a lot of insights like cold start, predicting popularity of this product, and so on, and transform them into index, which can be served by search engine. On the top, you have user interfaces, when you come to, let's say, google.com or zillow.com or like Apple Store, right? Interface which provides you like interface how to use search engine. Search assistance is a set of services helping you how to use search in the most efficient way. Like, for example, facet filtering, or like Typeahead, search after suggest, many other ways which helps you to formulate query. Query understanding, which helps you to understand, like if you come as a 3-bedroom house close to downtown Seattle, to parse this query, understand what exactly meaning, or it may be something different, how to classify, like you come and type something like for e-commerce site, Samsung TV. You understand that Samsung TV, but like what's the preferred range price and so on. There are a lot of other ways what's going on in query understanding. Indexing, which we discussed, retrieval, so given a query, understood query, how to retrieve the most appropriate items which are relevant for this query. Next big part is ranking, how to order these rankings with maximizing what means your customer satisfaction or revenue or probability to buy or something else. SRP logic, typically you combine multiple different results from multiple search engines, and there are a lot of other ways, like on top of ranking, what you want to apply. There are some policies, like depending on laws or depending on what, like policy restriction, like removing adult content and so on, depending on search engine. And then you have a lot of post-search applications. Like, for example, you can have safe search, then you get notification. You come to Zillow and search for houses, and then you want to daily get notifications which are new houses about, which satisfy your search request. The same applies to many e-commerce websites. So they're also the AI-based big post-search applications, and there are a lot of infrastructure like logging, monitoring, experiment management, and many other layers. So this is typical high-level architecture of the search engine. So for this documentation, there is like notation. I will, for this presentation as documents, I will say items which represent information about atomic search results which you care about. It can be documents like web documents, it can be houses, it can be web pages, e-commerce products, so like apps, items of interest. So they will be called documents for this presentation. So main components in this architecture and reference architecture, typically when I talk about search quality, you talk about search assistant services such as after suggest, dynamic facets, query understanding, ranking, logic to build search page, snippet building, universal search, and so on. Search infrastructure, usually when you talk search infrastructure, it means retrieval layer, but also logging, monitoring, operations, deploying index, all like what serve search results, but also like infrastructure to run it and operate it. Indexing is everything related to more data, from data acquisition, crawling data, consuming feeds, processing them, importing data, to data enrichment, duplicate resolution, removing duplicates, removing dirty data, cleaning data, mapping into some common understanding, data extraction, and final indexing, building index for retrieval system. Then post-search applications, this can be recommendation engines to search result based on searches you served, some other applications which you do post-search, and they're actually pretty important. Many search engines get a lot of traffic from them, and a lot of big part of company business is dependent of them. And search experience is view and design of search pages, result pages, and also like snippet building, how to present search result, like they're also AI driven, and they can derive a big part of the revenue for the company. And AI is everywhere in this text. So basically, typically, like there are many articles about AI in query understanding or ranking, but actually AI, and this what will be my presentation, first part of presentation about AI, is in every part of the stack, and actually it's important part of this stack, and it drives quite a lot of revenue for every company which uses this. So using AI components to improve data acquisition by 10%, indexing by 10%, just as example, everywhere, gives more gains and customer satisfaction revenue than applying SOTA in just one of these components and improving it by much bigger number, right? So, and typical most beneficial application of AI to search is building infrastructure such that you can apply AI in every part of search stack rather than focusing on one part of this. So AI development should be driven by creating infrastructure, culture, toolsets for continuous AI deployment, improvement, measurement everywhere in the search stack. There is no like engineering, other teams, every team is an AI team in search building. AI is not separable from engineering. So if you are AI engineer or AI data scientist, you are engineer also. Again, like improvement, like almost every AI task is very related to engineering improvement. If you improve index selection by 10%, it lets you accommodate more data sources to improve coverage, to improve ranking. And then like since you have 10% more memory, you can like have more information, more features for your ranking layer. Or if you improved infrastructure to decrease latency by 10%, it also lets you to make deploy more complicated ranking or query understanding functions, and within 10% of more model time, model inference time, you can deploy better ranking function or query understanding function. So AI is always very related to engineering. Engineering improvements lead to AI improvements. From many different points of view, just as one of the ways how they're related. And good engineering quality and culture is not separable from AI development and mandatory part of AI culture. So search engine teams benefit if there is like how you develop AI for search engine. One way you can like approach each of the tasks you met, the improving search as separate task, develop own infrastructure and so on. It works, but it does not scale. There is a lot of shared parts, right? And typically, once you develop complicated search engine, once you have multiple people working on this, you benefit from developing AI platforms or like run clubs. There are different names how you call them, right? So having some unified environment to train, deploy, serve models by reducing work on infrastructure, machine learning ops, sharing metrics across teams, making it easy to measure end-to-end metrics. There is not environment yet which will handle all types of AI development, AI serving, AI management, and AI measurement. Search systems are naturally complex. There are multiple different types of AI served very different ways in very different environments, written different languages, deployed like in very different ways. But there is always will be continuous work on developing AI platforms for your search engine. There are multiple ways how to deploy models, right? That's why I introduce also like different types of platform you need. You can deploy models on TensorFlow, TorchServe. You can deploy smart models served in container. You can compile model directly into machine code or some internal representation like source code, and then compile this into when it's like latency and through output critical parts of the AI applications. You can deploy models, and you can just continuously deploy new learn parameters, ton of other deployment scenarios. That's why there is not currently one AI platform which will serve all types of AI development in search engine. Multiple ways how you need to serve models in AI, let's say for document updates, and some other you need like streaming. Some frequently you need batch processing, frequently you need serving runtime services, like when query comes, you want to, within very short period of time, serve your models, understanding this query or ranking document. There are multiple ways how you serve AI models and such. Multiple ways how to improve AI models and search, or not AI, but in general. Sometimes you like certainly typical way retraining a model, but sometimes you need to change evaluation metrics because they really represents what you want to train your models for. You change sampling procedures, you change training procedures, you change modeling techniques. You model previously unmodeled tasks. You add new data, new features, and then accommodate them in your model to be used. You do infrastructure changes in serving, so there are multiple ways how to improve AI in search. So again, it's almost impossible to make one. There are like, yes, you see there are multiple AI platforms appeared recently on the market, but there is almost impossible to make one platform to handle all types of AI development and deployment. But like continuous work on unification, creating AI platform out of separate AI application scenarios helps companies to improve AI and to improve search engine based on AI. And there are a lot of open source systems like Kubeflow, MLflow, multiple others which are deployed now, which are available now as open source. And typically very few of them give you a full end-to-end scenario of using AI within your company. But what you do, you take them, you improve them, you work them, you build on top of them, and sometimes you use several of them. So like AI services in production, right? Good to have them decoupled because multiple small teams can work on services independently. And like to develop AI for search, you need many people, many teams working on this just by complexity of the tasks. But you need a varying between all of them, connecting them to each other, like signals which are produced of output which are produced by models in query understanding. Is needed a trunking layer to rank results appropriately, or something derived by indexing needs to be used again in ranking, and so on, right? So processing of query in search engine may call dozens of AI services. Processing a document and data acquisition and index may call hundreds of AI services. So performance considerations are extremely important when you build AI infrastructure for search. And AI infrastructure benefits greatly from common software practices, protocols, orchestration to organize AI cohorts and make order out of it. There are many other besides like machine learning objective functions and metrics which are used to represent your customer satisfaction, revenue, and other like business and customer oriented what you usually train AI for. There are multiple other functions and metrics which are very important for running a search agent oriented on performance, quality of engineering, and so on, like latency, resiliency through output, resource utilization, and they're all super important factors in design of every AI service in the search engine stack. And AI service development should be tested and benchmarked against them. And like as your model and serve billions of document updates, every improvement in latency through output is very important. Gives you big operation cost savings, gives other savings. So AI development is not just like as you read in traditional ML data science book about improving model with respect to accuracy or other metrics, but also about engineering metrics are extremely important. So there are two types of AI platforms emerge: horizontal ranking, they're focused on some AI features which are to be applied everywhere, and there are vertical types of model. They have a very different type of vertical types of platform, and they have very different requirements. So next step in my presentation, it was introductory part. I will describe AI, how is it used in every component of search stack by giving different examples from my experience, what my teams work on, what I know how it works, and what I show that AI is a tool to get significant improvement of every part of search. And so original presentation was 170 slides. I reduced it to be in time. But basically main message, AI is used in data science and machine learning is used everywhere in search and have huge benefit. And after that, I will describe what makes a good AI engineer or data scientist, what makes successful career in search, and what are important factors for long-term career and success in this area. So AI in search use cases. First, let's start with indexing. Again, frequently now, if you would search AI in search, you will get typically about query understanding, but it's just part of this. Like indexing, perhaps one of the first when AI was applied for indexing selection, like long time ago, and it's one of big applications of AI. Started in the 90s when web volume increased and index selection strategy started to be important. So decision, which documents should be indexed, which document to include, which documents to exclude. It's important not only about web documents, but if you build AI for e-commerce products, right? Do you want all of them to be in the index or not? Are they important to customer or not? So which documents should be indexed or not? Or typically many modern search engines are necessarily multi-level. You have small index for very frequently search items for very fast serving. Big comprehensive index for more rarely search items when you can tolerate also longer retrieval time, and which document to put in which layer. So index selection is very important AI application. Duplicate resolution, like assume you crawl web, you have a lot of documents which are duplicates of each other. The same applies if you are e-commerce, like can you get or any other, like you have like information about real estate properties from multiple feeds. How to decide that this item is this item or is a different item, right? And same applies for anything else. How to decide that these two documents represent the same item or similar item. And duplicate resolution is very important AI application almost in every search engine. Attribute extraction. So given description of documents about houses, e-commerce products, businesses, and so on, how to extract, how to make out of unstructured representation of information, how to build structured information of the structured representation of documentation. So it's typical NLP, but not only NLP. So given a full text description of item, a map into some multidimensional space representation of the same items. This important AI application. Another part of AI in indexing is the detection of adversary content. It can be explicit, adult, and so on, but also spam. Every search engine is attacked when, some vendors or try to misrepresent the items, so spam, misrepresentation of content, explicit content, which you don't want to serve for this type of queries. Any type of adversary behavior of content generators is important part of AI application and applicable almost to every search engine. Cold start. So given a new item, how do you predict, will you typically once you serve items to users, it's based on some customer behavior, will users be interested in this item or not, right? It can be for real estate, for e-commerce, for apps, in app store, for web. Given typically you derive this behavior looking into previous behavior of users who use this item. But you have new item, right? You have new e-commerce search engine and you have new Canon camera. And do you want to decide, do you want to serve this item for query like Canon camera or not? How to predict will users buy it or not? So cold start problem given a new item, having no behavioral data for this, but we know a lot about its entities. We know a lot of information about similar entities in the past, how to decide how to predict consumer behavior in respect to this item. It's another big typical part of AI applications, which is done in indexing time. Knowledge graph, right? So I talked previously about building attribute extraction given one item, how to build structured representation. But now imagine you have information about all items. Let's say it can be either real estate or it can be let's say information about maps, like about restaurants, laundries, about any points of interest, any businesses, or it can be information about e-commerce products. How to build graph representation of this information, because once you have graph representation, it's very useful for search, it's very useful for recommendations, it's very useful for multiple other tasks, which helps users, consumers find the items and to your company to serve them better, sell these items, and so on. So not just mapping items into space, but understanding what builds connections between items. Let's say if it's about maps, you want to understand that this particular restaurant is located in the city, which is another location, right? Both of them are no edges in the graph. It's connected to, let's say, this geographical entity by proximity, and it's connected by this brand representation of this restaurant by in-brand relationship, and many others. So given a set of documents describing items as full text description, how to build structured representation of the whole space, which will represent not only item attributes, but also connections and relationship between items. And then a lot of once you build index, a lot of statistical tasks, how to evaluate quality and size of the index, which is very non-obvious task, right? Is this index provides good coverage for the set of items you want to care about? You know that there is some real world of items, your index represents them. How to, you don't have full information about the real world, right? How to understand is your index has good information about, so a lot of statistical tasks. What categories are missing, what data quality problems you have, how to give evaluation of this. And this typical statistics, data science, parts of AI, technologies, how to build this, and this is also very important for every search engine. And then how to evaluate index size of external systems and so on. Data qualities, right? Like for example, how to decide what attributes are important, which must be mandatory or not, like using this information to drive your data acquisition process, sometimes driving your negotiation process. So AI is applicable not just in serving search, but actually to decide a lot of make business decision. And this data science AI techniques help you to drive business in the right direction. And then also demand generation, to understand demand, what you want, assume you have this behavior of users on your website, what they want to buy, well, how to predict for future forecasts such that your business make decision what items to buy, what items to acquire, what information to acquire will depend very differently on different businesses. Do you own this information? Do you sell items? But in general, AI evaluation very useful, and statistical data science evaluation is super useful to drive a business of the company, which is served through search, but actually it goes much beyond search. And this very big AI application, which also generates like billion revenues at big scale companies. Let's go to another part, AI for query understanding, right? What is query understanding? Query understanding is a mapping of customers' query into machine understandable format to retrieve a set of relevant items and rank them with highest probability of customer engagement. It includes like synonym expansion for better retrieval, like a removal of significant terms from query, correcting spelling and other errors, term weighting, attribute and entity extraction, a compound phrase extraction, classifications. There are many components, like in systems like big scale search system query, like understanding consists of like dozens of components, and each of them requires substantial amount of AI work. And especially as you go to international markets, of course, you have to do query understanding for multiple languages. It becomes much more complicated, much more interesting, since languages are very different, and so on. So parsing. Given a query, generate dependency, constituency, and other parsings is part of query understanding stack. Typically, this serves of other parts of query understanding per stack, but it's also one of the first AI applications inside query understanding. Classification. Given a query as whole, how to map query into a certain set of categories to be used in retrieval ranking, right? For example, most probable document category. So you assume you have a local search like maps, and someone comes into your search engine and types Italian, right? What does it mean? Because if you come and type in if you just look all businesses, and let's say in Seattle here, which contains word Italian, there will be a lot of very different businesses. What of them will be highest probability of conversion, right? In context of local search, typically, in this case, it means that users care about food, restaurants. So how to deduce that for this query, you want to promote these results rather than this one? It can be different. It will be different for like different types of search engines, different type of audience, but just in general, given a query, like Cinderella for e-commerce, you have e-commerce website, people come with query Cinderella. There are toys, there are there are DVD with movie, there is maybe online streaming, there is clothing for kids. There are multiple types. So what's Cinderella, right? What results will provide higher user engagement, customer satisfaction, and conversion? Another example, for local search, most probable distance. If you type gas at maps, you don't care about results than 5 miles further distance from you. If you're looking for a Michelin restaurant, certainly distance which you tolerate is much bigger. And query understanding function must understand this information, then will be used in retrieval and ranking functions. Novelty of results. When you come to e-commerce and type printers, right? Typically you would care more about new results. You would not care about products which are released 10 years ago. While for some other queries, you don't care about release date. So how to make system understand this information about user input? And then this information will be used in retrieval and ranking. And typically you have huge number of classifiers in search engine to classify queries. Similar queries, very important, which used across all types of query, like query understanding. Given two queries, how understand they are similar? What derives the distance between them based on user preference? Tons of application, given sometimes you have a new query which you never saw before, and many search engines have this big churn. You see a query which you never saw before. So how do you derive statistics prediction for this query? You never saw this query before. What you can look queries similar to this which you observed previously, use information about them, and to use for this query. And there are different notions like semantic similarity, user behavior similarity, and many other types. But this typical AI application which serves and gives a lot of improvements in search quality and the end revenues and so on. Term weighting. Given a query, how to understand importance of each term or phrase for topicality of this, for final topicality of the query. Entity and attribute extraction. Given a query, map into structured representation of entities and attributes to be used for better retrieval and ranking. Say someone comes with query like Samsung TV 56 inches, to understand Samsung is a brand, TV is a type, 56 inches is a screen size. But if someone types little black dress, it's not actually means size little, black color, dress type, not. A little black dress is just one category, and you must understand this is a compound word. And the same applies, let's say, for searches in real estate and any other search. Backfilling. So given a query and structured representation, do you want to serve only results which exactly for this query, or do you want to serve results which are actually close to this query, but users still may be interested? So like if you type, like 3 bedroom houses downtown Seattle, do you really care about only downtown Seattle, or we can understand that users can tolerate some distance from this? Or if you type, let's say, Nike basketball shoes, do you really care about the shoes only about Nike, or actually users will also convert into Adidas shoes, right? So backfilling, how to understand given a structured representation of query, how we can move it such that this representation will provide results still useful for the user and will still be generate customer satisfaction and conversion. Temporal aspects of the query understanding, how to understand a simple web search. People come and search for some conference name like VLDB, very large databases, right? And we have evidence that everybody this year cares about this particular page. And we have behavior-based evidence that users care about this one. In 1 year, people care about different page. How to understand this shift? Or let's say people come with some query president speech, how we can understand, or something else which change frequently, right? Or match score. It means very different things at very different sports season. How we can understand this given a query, how we can understand this topicality shift, and there are multiple different types of topicality shift. Some of them slow and continuous, some of them very sudden. How to detect and provide search results which serve user based by this or for these topicality shifts. AI for ranking. Perhaps one of the biggest applications, learning to run machine learning based ranking to rank documents, Litor, MLR, AI for unbiased ranking, how to use user interactions to create learning to rank framework. Frequently, it's one of the biggest revenue driver for search engines. I will not put much information on this slide because I have we're limited by time, and there are a lot of, if you look Google machine learning to rank, you have a lot of articles, presentation about this. That's why I will not go deeply, but it's one of the biggest AI applications in building search engine. But again, AI is used everywhere and gives big gains everywhere. AI for search assistance. So once you type, you come to any search engine like Google, Apple App Store, Zillow, Walmart Labs, Amazon, you type something, you see system helps you to formulate this query, right, by Typeahead. And it's pretty important from user satisfaction, especially from mobile devices, because it's very hard to type on iPhone or any other mobile device. And given once you type several symbols and systems gives you a completion for this query with high probability that this is exactly what you want, save a lot of time of the user, simplifies works, which also means user will convert with high probability, user will stay with high probability. So building type-ahead predictions, or sometimes they're called suggesting users their queries, is a very important and big AI application in search. Again, it's query dependent, it's user dependent. Sometimes it depends on your previous behavior, right? For example, if you're looking for real estate or local maps, and you look previously in some certain area, we understand that most probably suggestions from this area are more important for you than, let's say, some remote suggestion. And there are many other ways when it's user dependent. Or when you was looking for a certain set of products, we understand from this category products are more probable for your to suggest using other products. And AI for search assistance is another big application, again, generating big gains in both customer satisfaction and typically revenues, profits for the company. There are many other applications of AI across different search verticals, like, for example, image search, right? Typically, when I talked previously, most of this part were text-based AI applications. Text-based search would be web search, real estate search, local search, map search, e-commerce search. But there are many other search systems when AI is useful for other types, for example, image search. It's you're using AI, you can do object selection of object extraction from images. You can do image to image similarity. All of them are used to build your final system, which given image, search other similar images, or given a text, find images which provide information about which finds images about items described in your text. Many other, but these vertical AI applications where computer vision and other AI parts are very useful to build such system. Then deep understanding of geographical data for local search is another typical type of AI, vertical AI application. Whole page, right? This is what I described as SRP. Given output of several search engines, how combine them to construct the best customer experience flow? Like just for example, assume you come to Google and type, like something like Italian food, right? And you might have multiple different results. One can be like web, like some pages about recipes, or just generic food pages, maybe local restaurants. It can be YouTube with some videos about, it can be news. Given this output of multiple very different search engines, how to combine them and how to build the best consumer-oriented, such as like consumer-oriented representation of all these results from different search pages. The same applies for any other, like for example, iTunes has multiple different, like so almost every big search engine is actually a combination of multiple search engines. So how to combine them to build final representation, how to rank them across each other, and how to build, and also sometimes how to put ads information on the page is important, advertisement and other types, like how do you want to combine text information versus image representation. It's pretty important application when different AI techniques are used to build experience, the most useful, the best experience for the user. How to build snippets, so like how to build this more about set representation of search result output. But when we talk about representation of just one particular item, how to build the best representation of this particular item in your AI representation. How to generate like best text which represent item, how to generate a select best image, so looking for a house, right? And it has like 40 images which represent it. How to select the best image which at the search result page before going to the house page will give you information about the house. Or the same about e-commerce products, or about anything else. So how to create the best representation of the search item, which will give you the most complete, most again, from search result page, you can decide, do you care about this item or not. This is another typical AI application. Again, there are a lot of AI applications, like several articles were published. I did not work with this particular, it was theoretical, but seems a lot of interesting stuff. Applying AI to learn new efficient index structures. AI to predict index index strategies. This is more like for search engines, which are more traditional database search engines, but there are a lot of AI applications which prove that human can solve a lot of tasks which would 10 years ago would be considered like typical research work for researchers, how to find new index structure. Actually, AI does quite well. And also like typical DBA work, like given a database running, you want to select best index. It would be typical DBA work 10 years ago. And actually now AI is doing pretty well in solving that type of tasks. Then certainly search operations, right? Improving data center efficiency, placement data, placement components, how to place them across multiple different data centers, how to serve them. Then insight, or like it's another big AI application, predicting failing, or like failing nodes, failing servers, predicting what happens. Then like power usage effectiveness improvement. It's very important task once you go to large scale search. Actually, a data center costs a huge expense for your company. It's a really big once you run multiple data centers, optimized to provide low latency, high through output. You have a lot of copies of your index. You have multiple nodes serving this index, serving index. Data center expenses from electricity to, depending if you use like cloud providers, of course you use like AWS or Google Cloud, you use some nodes. This like data center efficiency is very big expense for, like a very big potential expense improvement for your company. And AI is very useful at that moment to predict your load, to predict your, like how many nodes do you need to serve them, how much memory do you need, what type of node, how many GPU nodes you need. So it's AI applications of AI to data center efficiency, to serving AI for search, is pretty important part when also companies get a lot of revenue and gains. Again, this is what I described before, how to generate final result page, how to place image, title, full text descriptions, attribute, reviews. It's actually not about search page, but about result page. So once you search the result page, search result page, right? And then you go to a particular result page on your server. Like it is not applicable to in web corner search, sorry, in web search, because you go to particular web pages which you don't have control. But in most other search engines, you control pages. Would it be real estate? Would it be e-commerce? Would it be like maps? You control page which represent particular business, house, product. What's the best representation of the item? Since on the page you can place images, title, full text descriptions, attribute, reviews, detailed descriptions, other recommended items. What's the best placement of them, such that what's the best design of the page which will maximize convenience to the customer, helps to make the right decision, helps to decide to buy item or not, to go look at this item or not. This and other AI applications which also actually makes huge difference once you apply it to customer satisfaction, to conversion rates, and so on. It's another very big application. Other like kind of not directly search related, but search by search engine, and another important, very important AI applications. Predicts the price of the item, right? So you sell something on your search. What's the price of the item which will maximize, and once you control price, what's the price of the item which will maximize user satisfaction, also will maximize revenue of your company, right? So you can make very low price, people will buy it, not necessarily actually, but you will have a decrease in revenue. So how to find, having this information about this price of this item on your website and your versus competitor price and so on, how to decide the best pricing strategy and make the price, the best price for this item. It's very important, very big AI problem. A lot of like here, like statistics, economic, game theory, a lot of different AI related discipline based, but this and other very important AI applications which can drive really how the system used by customers, how much revenue it derives, and so on. Performance, right? AI to predict performance load, to deploy new nodes, to serve increased traffic, or able to reduce traffic when you have a reduction of your load, to reduce number of nodes you serve, which also will decrease the operational cost. AI for, sorry, caching is incorrect spelling here, I mistyped. For cache is through CACH. Cache to predict what results query should be cached to improve latency, decrease load. Is another important predictive techniques which are used, and actually it can change quite a lot, like load time of pages on your website if you do it correctly, and of course also decrease load because you decrease load on the main search nodes and so on, and other big AI application. Then other application of search. So I was talking previously on typical search when you come type or give your location to the search engine, get results, but there are big new applications like conversational search, when you can actually talk to, like you can come and say, I'm looking for restaurants in Palo Alto. System asks you what type of restaurants? Italian. When it should be open? I want to have it open like during this evening, and it should be a nice romantic setting and so on, right? So conversational type of search is new appearing emerging application of search. It's emerging in almost every search applications, from a local web search to real estate to any other. So, and how AI is like used almost every type of this search. Of course, first is natural language processing, natural language understanding to understand what users say, but then dialogue step management, deep reinforcement learning, text generation techniques. Of course, if it's based on speech rather than type dialogue, automated speech recognition to understand for voice-based systems. So this is another emerging AI application for search. AI for search engine optimization, search engine marketing, right? So almost any search engine now is a lot of dependent on how traffic coming from search engines such as Google, right? Would it be e-commerce search? Would it be a real estate search? Would it be anything else? So how to present? I'm talking about, of course, a legitimate SEO and search engine marketing. How to present your search engine output, result pages, search pages, such that your search engine pick them, index them, rank higher, how to give best information on them, how to understand that this like search pages will represent what users search on Google. So how to build pages which will represent user interest and such that a search engine will pick them up, index and make available and bring traffic to your search engine. And the same for search engine marketing. How to decide best advertisement campaign, what's the best words, what's the best addresses to be searched from your website, what's how's it called in Google, sublinks and so on. So those are typically AI techniques which helps you to find these results. So there's a better way, get more traffic on your web search, get more traffic to your search engine, pay cheaper to get this traffic and so on. So those are also other types of important AI applications. And then of course, anti-SEO, right? I'm talking about legitimate SEO when you want to get traffic from Google to your web search engine. But if for any search engine, you find users who wants to manipulate your results, like to promote their results. Would it be App Store? Would it be e-commerce? Would it be anything else? There are users because, of course, people buy something and they get money, sellers will get money. So there are always users who are trying to manipulate your system and promote their items. So how to understand which items are manipulated and how to make your search engine output clean such that it will represent the most fair ranking of result from customer-based point of view to customers rather than someone trying intentionally to manipulate this. And there is a lot of behavioral analysis, data science, text analytics, many other techniques how you apply AI, machine learning, data science to detect manipulation adversary behavior in respect to your search engine. AI for question answering, it's another important part, right? When type of search, when rather than to find a document, you want to find answer a particular query. Like users comes, if it's local search, what's French restaurant of them is the most romantic in Palo Alto? Or like user ask query, what's the phone number of sales customer support for your website? What's the return policy? Like how can I find a particular agent and so on, right? So user ask you a query. User don't look for a document. User care about a factual answer. And question and answering is another big emerging part of AI. How is it applicable to search engine? And it's very different. Like it's like NLP based, a lot of but it's big part of new emerging search engine development. Post search AI, right? So after user came searching your website, save some queries, save some result. Can we still serve this user after user left website, right? Sometimes they subscribe, I am interested in 3-bedroom houses in Bellevue, and user saves the search. So how we can handle some results after they left by email or other means, such that it will be relevant to them, such that they will will not be overwhelmed with information. So how to generate best results after, how to serve them in the best way, and do other stuff. So this typical application of post-search AI, when a lot of AI, data science, ML techniques used to make the best customer behavior from this point of view. So this was part of about technology. And next part, I will talk more about career, what makes a good search engineer, how to prosper in this area, how to build good career, how to move, how to become better, good search engineer, and move up in career. So this part will be how to be successful in your search projects and qualities of good search engineer in long-term career, and how to be successful in long-term career building. So what makes a good search engineer? First, once you don't consider one particular problem when you ask build a particular, let's say, classifier for this type of queries. I'm talking about, let's say, 5 to 10 years building career. As a search engineer, it will be important not just to improve new models, but actually to improve new product features, to improve new business improvements, to improve something totally new. And for this, it requires quite big weight of knowledge. And like what I saw in every company I worked for, successful search engineers, actually, they must have quite broad knowledge. First, of course, machine learning, AI, data science. It's very important, especially in the first part of your career, to solve problem by using these techniques. But actually, then you must go quite well beyond. Engineering, right? Typically, it will not be just tuning models, training, and deploying. typically we'll need to build a systems which will deploy these models, run them with a lot of performance, quality, other consideration. And to be a successful search engineer must be as good engineer. Engineering is really important besides just AI, machine learning, data science. Next step, very important, to be capable to understand customer, but then transform customer experience into metrics which can be used for ML training and for evaluation of a system. Kind of be capable not just to understand customer behavior. I would say it's kind of more like product management feature and product management character feature, but also very important to connect this to machine learning and to connect it to data science, how to express, how to understand customer, but how to understanding customer build numerical features which will help to us to improve our systems. It's very important quality of good search engineer. Of course, statistics is very important to design analysis of experiments, because just model tuning for deploying model, getting new accuracies just will be very small part of search building experience. Important to be capable to design new analyze experiments well beyond just deploying new models, and how to understand, analyze them, not just to say it's good or bad and we have this confidence interval, but what makes it good, what other features to deploy, and so on. And of course, in long term, it becomes important, especially as you lead teams, understand business of your company, understanding business, how to transform business into metrics, OKRs, new search features, new product features, new search products. Those kind of knowledge-based qualities of good search engineer. So again, especially as like your individual contributor part of career, it becomes very important to be capable to transcend of some small part of search stack and be capable to other work, but all like as individually contributing, but also working with teams, working on other types of search stack. Typically developing like once you develop one model for some particular feature, it's fun. But once you start working on really big company level products, necessarily will interact with multiple different teams in search, indexing, ranking, query understanding, evaluation, set types, statisticians evaluating your change. Once your changes become big, multiple, like dozens of people, it will necessarily be very diverse teams. But also it will be not only engineering, it will be research teams, will be statisticians, machine learning engineers, and at later level, it will be also maybe business teams, it will be legal, like as bigger change in search engine, affecting billions of users, affecting maybe dozens of engineering working on them, will necessarily affect multiple different teams. And for this, it's very important to have capability to collaborate at very large scale. It's like communication skills, document writing skills. Even if you're not project manager, it will require some management level from you, and the same to product management also. So these skills are very important for search engineer as you go from individual projects to multiple big projects affecting whole business of the company. Another important feature is like this resiliency, right? Frequently, many search features will be like success is not guaranteed as you start them as any big project, and frequently it requires a lot of experiment until you succeed. And making this like going from failure to succeed requires this particular capability and another capability to have long-term focus, sometimes working on isolated results, especially as you start. But then also like it's another important capability of search engineer. Again, the capability to work on long-term projects with no guaranteed outcomes. Many of such projects are focused on improving certain customer satisfaction metrics, and guarantee is not like there is no guarantee that it's achievable, especially as big like projects. When you have a big ambition, we want to improve like certain feature by big number. It's not guaranteed that we will do this. It's not guaranteed that it can be done using existing hardware, information you have, set of models you have, and many other dimensions, right? So going this certain persistence to go through failure to failure before finding successful solution is very important part of like this kind of research type of mindset is very important for search engineer, rather than for, let's say, some traditional software development. When you go from Scrum to Scrum, project is split into small parts. Each of them will succeed with very high probability. Here, like moving from failure to failure until you succeed is very important persistence feature, which is required to become a good search engineer. Then also like especially as you go to new, like rather than deploying particular model, but like once you affect and you start creating new types of models which affect your search engine, new types of features, understanding the customer, transforming understanding the customer into metrics, numerical features, and not just some numerical features, but understanding this numerical feature can be actually used to evaluate your machine learning model, or can be used to train machine learning model. So a lot of like search development is not about continuous improvement of one relevance metrics. Actually, a lot about this, but not everything. But extracting, understanding various aspects of customer satisfaction and transforming this understanding into metrics is another important capability for search engineer. And of course, like as new search engineer, very important is not to be fixed on set of models which you learn during, let's say, your PhD career or during your master studies or during your first year of career. It's very important to be continuously like reading, understanding what are new types of techniques, a new type of model deployment, what new types of feature engineering, new types of something else. So continuous, I will talk about this a little bit more later, but continuous professional development, learning, reading is very important for successful search engineers. And then, you know, like very important, especially as you go to big projects, like, you know, like one typically in search engineer career, you start working someone like your manager assigns you a project, like improve number of relevant foreign results when the user really care about foreign results or whatever, right? Is like as you go move into up in your career, it becomes, you will come a lot of projects which come from you. You will see a lot of stuff which other people don't see, and you want to launch projects, and sometimes these projects will require big resource allocation. It can be big hardware allocation, like multiple machines in data center, or a big team, like multiple people working on your projects, or some change of work of other departments, right? And capability to find and support and convince people with very different points of view. As you talk to legal, as you talk to business, as you talk to marketing, necessarily they will have very different, like other engineering teams, they will have very different views of what makes important, what is criteria of success for our company, and how to convince them about hardware, like hardcore, like machine learning, AI projects, that this project is very important for companies. This capability to convince people is very important, like very important what is required from a good search engineer. Like again, coming back, because I think it cannot be underestimated. It's like super important. And sometimes I see it's a little bit neglected in literature, but good search engineer is engineer. And engineering part is super important and frequently, underestimated. So like it's like being a search engineer is not only about deploying new models in some environment. It's creating environments to train new models, because never one AI platform will serve all parts of search stack. And to solve the task, you have to create them, how to write good code for them, how to write good test automation suites, how to make it working with your very strict performance limits. Typically, search engine has very strong performance limits now, low like latency through output. If you do something wrong, right, most of customers come to your business through search engine. The search engine is down, business is down, right? So like how to be a good engineer is this super important part of search engineer, and AI engineer and data scientist in search. This was about like more search engineering. What another important factors to build long-term career? So like, you know, like if you move from one company to another, right? If you move from a big company to startup, or opposite back, right? What helps you to build your career in 10, 20 years plan? And like what I see in our technology environment, certainly reputation is #1 success criteria of long-term success. And reputation is not only with engineering teams, you're not your direct teammates, but with business team you work with your peers, with your leadership, right? Leadership reputation based on very different qualities, from your engineering quality of products you deliver, from building large-scale system to what you are as a machine learning engineer, what types you help to solve, but how did you work with legal, how did you work with recruiters, and so on, right? So building this reputation is like, you know, like from my observation in Silicon Valley in general, in tech is a #1 important long-term criteria goal, why people grow up, why people hire in good companies and good teams and so on. Another, especially like very important, what I saw is like selecting job which truly suits you, right? Sometimes people move because they really care about getting higher title or immediate higher salary or something else. And in long term, it may hurt career because you work in an environment you did not learn something new, you did not enjoy something new. So very important once you move to one and think about next job. It's look into companies, not just like what's the most biggest hype. Everybody talks about the startup now. They got a lot of funding, $1 billion or something. And frequently it's not something really good for you. So it's like understanding deep value, understanding deep about company, what its technology set, what its values, what its culture, what's its technology area, what its like vision for next 5 years, right? It's very important that to select at every step company which suits personal you rather than generically known company, big company, and so on. And especially it's very important for the first job after master or after PhD, because like what you will learn will decide your career for next many years. And to select the best company as the first company which will you enjoy, which you learn a lot, which you'll move up in for like from many points, like like as leader, as engineer, as individual contributor, as collaborator, is super important. So like very important to at every step of career move to think what's this next company and select it appropriately for you. And it's not just first, it's next, it's for every step of your career. So be sure that company culture, values, product, engineering fits you, your development goals, like think about your development goals, your values. Don't move because of popular technology, big title, sudden salary increase, hype, as accidental to long-term career success factors. Another very important to focus on development of long-term professional relationships. Whenever we work, right, not just be successful with your projects, but also create a lot of like meaningful work connections with people, teammates within your company, but very important to create long-term relationship and knowledge of people working in other engineering departments, and it's good like how you create this. You expand your projects, right? You work, let's say, in query understanding, but then you think how to make bigger projects which will interact also with indexing team. And it will necessarily, of course, make you interacting with indexing team, or like how to make more, bring some innovations from research team to my engineering development team, and then necessarily work with research team, or how to affect business development, right? And then necessarily work with a business development team. So develop diverse base of meaningful work connections with different technology departments, but even different lines of business, marketing, legal, recruiters, which based, of course, on your reputation, of course, but select also projects, select your impact such that you grow as in your career with big impact on company business, but also it helps you to create a very diverse base of meaningful work connections with multiple different teams, which will help you in your career building. Another inside company is very good to move to more strategic projects, like with big impact on the company business. Of course, it will help you with career development, with moving up, getting more, but also it will provide you more meaningful connections, and it will give you like usually big impact projects that are also typically more interesting from technology point of view, more to learn from collaboration, more connections with other technology departments. So they're typically more interesting. So long-term career success typically related with moving to more strategic points for the company. And then, of course, move to more strategic and big impact contributions in your area of your work, from individual projects to team projects, from coding and model training to like kind of be responsible more for end-to-end projects. And then as you grow, to grow size of the projects and be responsible, not just someone tells you, create model to create this metrics, but like what exactly vision for our company for this particular type of search, what customer satisfaction there, how to create metrics which represent customer satisfaction, what strategy we have to have there, what roadmap to develop, how to execute, how to build team, how to hire people to this, right? So growing in this area helps career a lot. So basically being in search, but then growing in like what contribution you go from individual contribution and building new models, developing new models to actually defining some big core areas. And as important, value, I think valued in almost every company. Like everybody can spot when company doing something wrong. Like we have wrong technology here, we have wrong business here, we acquire wrong data here, right? Everybody can spot and bring this. And a lot of complaints you see. What really works for career success is not to bring complaints, but bringing ways how to fix them, right? Maybe sometimes your complaint will be well beyond your current role, right? You notice something really big in company, but even at that level, you contact VP or CTO, whatever responsible for that. Don't just complain that I see something wrong. It's good, but bring us your proposal for solutions, how to fix this, right? Fix whenever possible, but when sometimes it's like, like it can be like at the beginning, you see some wrong code, some wrong play of work, you do it by coding or writing documentation. But then, of course, as you grow in career, there are higher levels, how you can do by rework, by bringing more people, by doing something else. Or sometimes you have little power to fix at that level, but even at that level, when you have no power, don't just complain, but actually bring solution proposal. Maybe it will not be accepted, maybe something else. But for your reputation, it's very important to be solution bringer rather than just complaining. Like I think I just 1 second. Yeah. Very important what I said before. And I noticed many people stop doing this once they move high enough. I think it's very important never to stop it, and very, very important to be very busy at your continuous career development. Of course, it's very different for different levels of career as you move up, right? Would you go as individual career, individual contributor up as you go to manager, or you go to some other. It is very important to have in each role continuous career, like professional development, not career development, continuous professional development related to your area. Like every 12 months, ask yourself, how much I learned about technologies, products, services, markets related to my business, related to my markets. What part of this knowledge relevant to my work? How much did I help to improve my performance of my team? How much this knowledge help, and what knowledge I have to acquire next year? Another, like what I said about building meaningful connections. How many new people have I gotten to know at work? How diverse is this people set? How many people I improved relationship? How it helps them? How it helped me? So how to expand this my set of meaningful connections, professional connections. Other like types of this continuous professional development. What new results, accomplishments have I achieved at my position? Did I was just engineer, just bringing solving problems, or actually I make something very, or leader, just being a manager in this position? Or what actually big meaningful accomplishment have I made for my company? What have I launched, improved? How much did I improve this? How much did it add to my reputation? What's my track record based on this? What new skills I developed? Like previous was more like just about knowledge, but here it's about skills. Did I improve my skills in communications, technology, analytics skills, my judgment related to this type of business? In which areas? So this continuous development is crucial, very important for continuous career, career improvement. And I think it's frequently again underestimated, but it's very important. Yeah, I think that's all my presentation. So 1 hour with a little bit. Yeah, please ask questions. I would be glad to answer.
If you go and hit the Q&A button right next to the share screen button, there should be a few questions already in there.
Okay, but let me open it. Back to meeting. 1 second. Somehow, if I click back to meeting, it does not. 1 second. I see Q&A. Okay. Yeah, how much data does a web search engine need to hold today? So if you consider a big search engine at Google scale, so consider like 15 years ago, meaningful web was several billion of pages, and like big web was like say several dozens of billion of pages. Now meaningful web is like, which important for your search would be several dozens of billion pages, and whole web will be closer to hundreds billions of pages. So like if you want to build a new search engine, which will be, at least from index size point, I talk about comprehensive search engine, not particular, let's say you want to build search engine about local businesses, but about whole web. You would need to build a business like, I would say like 20, 30, 40 billion pages would be a minimum number which you want to build. What's my opinion of PyTorch versus TensorFlow? Yeah, it's a very good question. We use currently we are a little bit more PyTorch based, but we are not restricted. Certainly TensorFlow has a lot of advantages for serving, for building production pipelines. PyTorch is much better for fast experimentation. Like we're not restricting like our team now. We are trying to use both, and like maybe like I don't want to go to any kind of war and fighting here. I believe both of them are useful. Certainly, each of them has like TensorFlow is strong on serving serving part. PyTorch, we did not study, we did not use PyTorch serving new one much yet, more like experimenting with this. PyTorch, of course, is much better for rapid experimentation. So I don't have any strong preference now. Both of them are used in my team, and both of them are useful. What would be an effective way of indexing and classifying a structured text document that are domain specific, such as medical or legal domains? Can standard search techniques apply? What would be like? There are several questions here, right? What effective way of indexing? I mean, there are a lot of techniques for indexing. It depends on what types of search do you want, right? There are like standard like informational retrieval books about indexing. Like when I was working in one big search company, we were like again, many search companies has own search engines like Google, Bing, Amazon, right? Like if you want to index document at that scale, it's certainly for you, it will save a lot of MLOps, and then you need a lot of flexibility. It's better to develop your own indexing agent. If you want to build some domain-specific search engine, medical, legal domains, you don't want to build team focus on basic information retrieval techniques. You don't really care how much you can compress index because it's not the biggest price of your change. You can use Elastic, Solar. There are several other search engines which are fixed on like indexing. From that point of view, you can use a lot of like already implemented in open source techniques for indexing. You don't want to go deeply and learn what like index information retrieval for this part. For classification, right? Effective ways. Like currently it's proves like there is a, I would say, quite new direction based of deep learning for NLP, but they're very effective in accuracy and indexing, and also currently you can build quite good in serving time depending on your latency through output requirements. If you have very strict requirements there, like a fast text from Facebook is pretty good to build a lot. And then of course for classification, frequently work very old techniques based. You can use SVM. You can use like even classical textbook naive Bayes. They're quite good for many tasks. So depending on your task, for classifying, there are very big selection of techniques based from like very traditional NLP techniques to a lot of modern development, and depending on accuracy requirements, depending on your domain, depending on like what your classification said. Depending how big is your training set you can afford to create, depending on your latency output requirements, there is a very big techniques. It's a very classical set of problems. So, yeah, certainly I will share presentations. There are several spelling errors. I will fix them. I will share my presentation. Okay. Yeah, will slides be available? I will make them available. Thank you for excellent presentation. I especially enjoyed the first part. Thank you very much. Please look at my chat comments. How can I open chat comments? 1 second.
Chat comments is the same. It's just hit the chat button right next to the share screen box.
Is it possible? I don't. 1 second. I don't see chat comments here. Is it possible to share about AI ethics? If you can share the same comments here, would be awesome, because I don't see chat. Or if someone can read them, I don't see chat comments.
Sure.
1 second. 1 second. I found where I see chat comments. 1 second.
Perfect. Thank you.
Oh.
Perfect.
Have you read Weapons of Mass Destruction book? Yeah, I did not read it, unfortunately, yet. I know about this book. I read about this book, but I have not read it. Yeah, I think it's good. I have very big reading list to plan. Maybe I will put this and read it by this fall, this autumn. I did not read this book yet. Yeah, about biases in data sets. I can talk a bit about this. I think it's a very important problem. Like I can tell you, from my career as I built career. Like, there is a lot of discussion. Perhaps you saw Jan Legun versus other people, like what makes like a good and bad AI, right? And there are some people claim once you have a bias in a data set, AI engineers should not care about this because it's just bias in a data sets. I disagree with this. Like even much before of modern ethics, most of my career in AI was built around solving biases in data sets. Maybe they were not ethics related, but they're still bias in data sets. So let's consider you building a ranking function, right? And typically ranking takes, I just give you an example. Ranking takes into consideration behavior of users in respect to query and search results. And of course, there is always bias there, which is called position bias, right? And if you want to build a good ranking function, fair ranking function, which gives the best ranking results, you have to remove this. Bias. Nobody says in ranking community, oh, there is a bias in ranking. Like in results, we don't care. It's not algorithmic problem. Everybody considers this as algorithmic problem. The same, you build a, let's say, behavior-based ranking for queries. And like typically for query, you have a lot of old information based on previous ranking, previous behavior of users based for this query, and you have new results. If you consider yourself only new results, you remove time-based ranking, but you have less information. If you consider all user behavior for this query for multiple years, you are like, or depending, like there are a lot of course, policy restrictions, legal restrictions for available time. You will get a lot of data, but you will have bias based on just that behavior 1 year ago was different than now. And nobody says, oh, it's just bias in data. I don't care. It's not my problem. No, it's AI problem. So what I believe, like bias in data, not I believe, actually, it's based knowledge on my experience. Bias in data is always AI problem. It's algorithmic problem. And a good AI engineer, AI company should solve this problem first, of course, thinking how to remove bias in data. Sometimes it's unremovable because you get data from external sources. So how your algorithm will solve this problem, how your algorithm will solve a bias in data problem. And frequently it's solvable to a very big extent by algorithmic, not just by working on data, but algorithmic ways has to understand how to remove bias in data. And of course, it's applicable. People were always working this in ranking and query understanding, removing biases based on behavior and anything else. And certainly it's applicable to all modern problems which we have now about race, about like many other like I would say demographic, any other based behaviors. Certainly, I believe like any biases which are represented in data sets, which currently algorithms learn, well, we as AI researchers, as AI data scientists, as AI engineers must work how to create fair systems which produce as maximum as possible fair results, even assuming that there is a bias in data due to some historical or whatever other reasons. How about understanding ethics or what you're working on impact on society to prevent issues like many? Yeah, for us, it's very importantly, like, ethical issues are very important, and we're doing our best how to create fair ranking, query understanding. Like, as I said, I believe it's work of AI engineers to remove bias or any other ethical issues in data. And for me, my team is quite important to produce best, fairest ranking, fairest search, and so on. Yeah, thank you. So I think I answered it. If you have more questions, I would be glad to answer.
Looks like that's it. Thank you so much for coming, Andrei, and thank you everyone else for attending the talk. We hold these talks to keep people furthering their learning and to go along with our education data science program. So please, thank you for joining us and enriching yourself in that. Please, if you haven't already, to make sure to subscribe to our YouTube channel and comment about what you think about today's meetup or what you thought about our new online Zoom format. Please also join us on Friday for our scheduled meetup, Friday, July 31st, that is, and it will be another edition of our AI in Healthcare Talk series. Thank you so much, everyone, and have a good night.